Okay, so let's discuss De Morgan's theorem. So De Morgan theorem has two laws, law 1 and law 2. So in law 1, it states that if x plus y complement is there, so it, it will be equal to x complement into y complement. Okay, and in law 2, if x into y has a complement, so that will be equal to x complement plus y complement. So these two laws you have to remember. Okay, then let's see duality. So in digital circuits there is something called as positive logic systems and negative logic systems. So in positive logic system, if there is a square wave and its value this value is 0 volt and this value is plus 5 volt. So in positive logic, plus 5 volt in digital is represented as 1, whereas 0 volt in digital logic is represented as 0 in positive logic. But in negative logic, what happens is, if we take the same square wave, it will become opposite. Okay, so here plus 5 volt is represented as 0. Okay, and 0 volt is represented as 1. So it's opposite in negative logic systems. You should just know this thing. And then so in an expression you will probably need this, okay, to obtain steps to obtain duality. Okay, so it will apply for positive and negative logic systems. Okay, so steps is, if in expression there is and, you convert it to or and vice versa, opposite. Okay, and interchange 0 and 1 to 1 and 0 and vice versa, anything. Okay, so let's see some problems. So question number 1, the positive logic expression y is equal to a plus b, obtain the negative logic. So if you see steps to obtain duality, change and to or and vice versa. So if you see here, this is or function a plus b, right? You see here a plus b, so plus is there, right? So you make it into and. Okay, so that will become, for negative logic, that is means duality, that is the duality thing. So it will become, plus will become into, and variables will remain safe. So this is in negative logic, this is in negative logic, this was in positive logic. Okay, next question, we have to find the dual form of this expression. So again we'll see these steps, change and to or and vice versa, like make it or to and interchange 0 and 1 to 0. Variables remain same. So if we see here, if you see now, there are two variables here now, correct? So there is one dot in between a b, so you will make a plus b. Okay, then comes this plus you have to make what, multiplication, right? Dot. Then comes a bar c, that you will write as a bar plus c. Okay, then again plus is there, so dot, you are just changing, then bc is there, so b plus c. So this is the dual form of this expression. Okay, now if you, now here a complement of this expression is there, so we'll apply De Morgan's theorem. So we'll get what, a bar into b bar into c bar, De Morgan's theorem. Okay, very important. Then there is this reduce the expression. Okay, fine. So to tackle this kind of function, when you have to first start with this longest bar. Okay, first longest complement is there, right? So this thing and this expression, you treat it as a De Morgan theorem. Okay, So it will become like xy bar was there, right? So it will again get one bar, and since plus is there, De Morgan theorem into x bar which was there previously, because of this one more bar will come, then again into, then xy, then bar. Okay, so double complement is here, so it will become xy into x, because double complement, into xy bar. Okay, so here you will notice this xy and xy bar is there. Okay, so suppose xy was 1, so xy bar will become 0, correct? So 1, so so it's like 1 and here 0, and all multiplication is there. So anything multiplied by 0 will give me what? 0. So the answer is 0. Okay. Okay, so now the Boolean expression xz plus yz is equal to what in the 4 of the following. Now if you see, it's like if you see the options, they are like increasing in variable, they are not reducing. Okay, so what we have to do is, this is one technique. So you take xz and here plus y z bar is there, right? So if you see this has 3 variables, this expression. There is one x, then there is one y, then there is one z. Okay, so what you do next is, xz is there, right? You multiply it with y plus y bar, that is y plus y bar is equal to 1, correct? So we can write it like that. Then we take yz bar, which is the third missing variable, that is x in this. So you can write it x plus x bar. Okay, because x plus x bar and y plus y bar is equal to 1, correct? So we are not adding anything extra to the expression, that's why. Now if we just multiply, we get xyz plus xy bar z plus xy z bar plus x bar y z bar. So this is our answer, the fourth option. Okay.